when we look back at the simple React application that we have been developing in this course, it's fairly straightforward. It has a dozen or more components that we have organized into a hierarchy, and then we have the main component that is acting as the repository for the state of our application. And any of the other components are purely presentational components, and any changes that they want to make is reflected back to the main component, which then modifies the state. Now, this approach works very well for very simple React applications. I mean, toy React applications that are useful for teaching. But when you go out into the real world, you might end up with React applications that could consist of hundreds of components and organized into multiple hierarchies and not necessarily connected with one root component. They could be organized into multiple groups, and each group with a central component that is managing the state for that group of components, and so on. But in such a situation, maybe you make a change or you initiate some change in one particular component by, say, for example, responding to the user clicking on a button or the user inputting some information into an input box, and then you propagate that up to the root component of that branch of the tree. Then the change that has been caused might actually affect or may result in the need for re-rendering a component which is in yet another part of this whole structure there. And if the two don't share a common ancestor, then it is very hard to pass this information back and forth between them. Now, the simple React approach that we have taken with one root component that is holding the entire state of the application will not scale in that situation. So it is better to move the state of your application into its own separate unit in some way. And this is where the model view controller approach that we just talked about might come to our help. Because in the MVC approach, we see that the models capture the entire state of your application, and any changes that you want to make to the model from the view will have to go through the controller to the model, and then changes to the model may result in the views or some parts of the views being re-rendered. Now, the MVC, of course, is a wonderful approach and has been very effectively used for many web applications. But when it comes to React, does it work? And the other question that comes about is, what is this Flux architecture that we are talking about, and how is this relevant to the MVC that we have just discussed? Let's talk about these in this lecture. Now, when React started out, React was touted as the V in the MVC, and that was the way it was being approached earlier. But nowadays, we no longer hear that kind of quote-unquote view about React. So it has gone beyond being a simple rendering of the view, and you see a complete React application being developed. And indeed, the simple example that we have seen so far, you have a full-fledged React application already in place, and all that you need to do is connect it to a server through using a HTTP protocol support using something like fetch, which we will examine a bit more in the next module. But if you do so, you can easily have a fully functional React application. But that doesn't scale very well. And this is where you want to move to a full-fledged MVC approach, where you capture the entire state of your application and move it into a model, and then let that dictate how the views are being rendered. Now, the MVC approach, when used by Facebook, they encountered certain issues with the MVC approach. Now, there is a very well presented discussion in a talk given by Facebook on why they faced issues with using the MVC architecture in some of their applications. And I have given a link to that when in the Flux documentation that is given in the additional resources of this lesson. You would see a video where one of the Facebook engineers explains why the MVC causes problems for them, or caused problems for them with the issues like cascading updates where one change in one model may result in that causing a change in another model, and which causing a change in another part of the model, and so on. And this cascading updates of the model state pretty soon becomes very difficult to handle. And so they found that this approach of the MVC approach doesn't work very well with their kind of applications, especially things that they develop with React. And that is where they came up with their own approach called as the Flux architecture. What exactly is the Flux architecture? Again, just like MVC, it is a software engineering pattern. It is a suggested idea or a pattern for you to organize your code, and not necessarily the only way of doing things, but they found that the Flux approach works very well for applications like what you develop with React. Now, what is the salient feature of this Flux architecture, or the Flux approach for developing applications? In this, one of the salient features is unidirectional data flow. The problems that they encountered with MVC was the fact that the updates, as we see, lead to a cascading flow of updates within the models, and becomes a tangled web which becomes untenable after a period of time. And so this is where they decided that all updates have a unidirectional flow, and the way they suggest is as shown in this picture. So here, the central unit for your architecture is the store. In the Flux architecture, you could have multiple stores. What is the store? The store becomes the storehouse for your application state and any business logic that modifies the application state. So the store encompasses this whole thing, and the only way you can modify your application state within the store is by requesting the store. You don't have any setters that the store makes available to you. So modifications to the state is completely controlled within the store itself, and that dictates how the modifications need to be done. You can only request for changes to be done to the state through actions, which are sent to the dispatcher. So the dispatcher becomes a controlling unit for serializing any actions that you request for changing the store. Now, the store itself can be subscribed by views within React, or in general, controller views. So like the main component that we saw in our application, the main component was the storehouse of the state there. Now this main component will get its state from the store of your Flux architecture that you implement. Now the controller views subscribe to the store, and they will have access to getters on the store. When the store updates its state, the store will emit a change which the controller views will watch for. Whenever a change is emitted, then the controller views will go back and be able to get the updated state, and this in turn may result in re-rendering of parts of your views or parts of your components within your React application. So that is how the data flows. But again, it is a unidirectional data flow. Now the views cannot directly change the store. If a view needs to change anything in the store, then this is the approach that they expect you to take. So any change that you want to make in your store because of a user's interaction with any particular view within your application will have to be reflected back to the dispatcher in the form of an action. Now the actions themselves support what are called as action creators. Now we will talk about some of these things in a bit more detail in the context of Redux, which we will discuss in the next lecture, and we will adopt Redux as the approach for designing the support for our React application, or the overall architecture for our React application. We'll talk about that in the next show. Redux is somehow related to Flux, and so many of these concepts, the action creator, the dispatcher, the store, and all that will come back again, and I will discuss more about this when I talk about Redux in the next lecture. But that's the approach that the Flux architecture suggests for you. So new actions that are initiated will propagate through the system in response to the user interactions, and this will be delivered to the dispatcher. And the dispatcher becomes the central unit that controls all the changes and mediates to ensure that changes to the store are sent through it. There is no other way for you to change the state of your application. So this approach, where there is a unidirectional data flow, any changes have to go through the dispatcher and then be sent to the store, and changes to the store will be reflected into your controller views, or through by the store emitting the change, and then the controller views then pulling in the changed state through getter operations on the store. Setter operations, as you see, is not available on the store at all. And so the only way you can do any changes is by sending actions into the dispatcher, and the dispatcher then serializes these changes to your store. Now, again, this may seem very, very abstract to you at this point and may not make much sense to you, but when we discuss Redux in the next lecture and then go on to the exercise where we apply Redux to enhance our React application, it will become even more clearer on this unidirectional data flow and the store and what role it plays in storing the state of your application, and how we modify the state through actions which are supported through action creators and action types and so on. Again, I have thrown a lot of terms at you. Hold on, we'll come back to them in the next lecture on Redux.